Hello, everyone. This is the lecture on functions in Python. So what is a function in Python? A function is a set of statements that are grouped together in names that can be run more than once in a program. So what that means is something like a function to square a number. It could be helpful because rather than writing x or whatever your number is times 2 every time, you can just write that one time and then call it from multiple places. At first, it doesn't seem like it's that much easier to do that than to just write x star star 2. But then when you think maybe your requirements change and you need to now cube the number instead of squaring it, if you have x times 2 in 15 places in your code, you've got to go through and change all of them and make sure you get them all or you'll have an error. But if you just got function calls to that one place, then you just change the code in that one place, and then it's changed everywhere. So take a second to think about the differences between a Python function and a math function. And we haven't gone too deep into what a Python function is yet, but I'll pause for a second. So a math function, is if you remember from whichever math class you learned this in, it's a one-to-one mapping from one set to another set. And the important distinction here is one-to-one. In Python, or in most computer science languages, a function doesn't need to be unique. So you could have a function that returns the same output value for every single input value, for example. It doesn't need to be a mapping. And so a little more on a Python function. Here we have an example. They're defined with the def keyword, so that you put that before the first time you write or where you define the function. And then you indent in to have this code be part of the function. So anything that's indented at this level after the def is part of this print time function. Give it the 2 parentheses. Inside the parentheses is where you put the arguments, and we'll see that in the live coding in just a minute. And then down here, today equals today.date or date.today, and then the print, that's the body of the function. This function doesn't return anything, but functions can have return values as well. So here, this is bottom part is the if statement that runs your Python code if you're running it outside of like an IPython interpreter like Spider. And here this is necessary to actually evaluate your function. And so the output today's date, if we had recorded this lecture on 2021-04-06, that's what it would print out. So here we have a function with the docstring, and rather than just showing you this, we're going to actually write a function. So we're going to write a function to take the square root of a value. So we start with the def square root is what we're going to call it, and this is going to take in one number as an argument x. Then here we type int, so x is going to be an integer. We're only allowing, actually, let's make this more interesting and allow floats as well. And then it's going to return after the arrow a float. Now we have our docstring. If you type, they start with 3 quotes, and Spider IDE will come up with the generate docstring, which is pretty helpful. It fills in all this stuff for you. So the first thing you need is right up here with the quotes, a quick description of what this does. So this function is going to takes the square root of a number. X, we fill in this description here. Number to take the square root of, and then it's going to return. Oh.
I didn't get that. Could you try again?
Convenient Siri. It's going to return a float, which is the square root of a number, of the number x. And then there's one more section that hasn't been automatically generated. It's the example section. And this is important for testing. So here you write three greater than signs, which is the Python terminal thing. And then you write your function call or an example of using your function. So here we'll take the square root of 4. And then under it, you write what it should evaluate to. So the square root of 4 should be equal to 2. And then we'll do another one with a float. I don't know the square root of 2.5 off the top of my head. So we'll just do 2.5 squared as our input value. And then we'd expect the output to be 2.5. This will be 2.0. Now we write the actual body of our function. So this is all documentation, and it really helps to write the documentation first and then just fill in the code afterwards. So we've got all of our documentation we need. We know we get x and as a float, and we need to return a float, which is the square root of the number x. So here is the return keyword. This says what to return. And it returns the value of the expression that comes after it. So we'll do x to the 0.5 power, which is the same as taking the square root. And that should be our function. Now to run these, we can type something like square root of, let's say, 16, and run this, and we'd expect, oops, we have to print it. Printing the square root of 16 is 4.0. So that seems to be working as expected. But since we wrote these good examples, let's see how we can use these examples to actually generate some test cases in case we change something later and maybe mess it up, then we'll know right away. So I've got a little bit of code here. This will also be provided in the lab template for the next lab. If name equals main, that's just saying if this is the file being run, then do this. If it's being imported from somewhere else, then don't do this. It's going to import doctest, and it's going to run doctest.testmod. That is test module. So it's going to test all the functions that we have written in here. Great, and so we see we run this and we get no output. As we learned in lab on today, no output is good. No output means that everything worked. If we change our examples up, let's say the square root of 4 is actually, we're going to say 1.0. Then now we would expect this to throw an error. And sure enough, when we run it, we see failed example, square root 4 expected 1 got 2. And so it's generating tests, and that gives us a really high amount of confidence in our code when we know that it's covered in tests. So let's say we wrote correct tests and everything's working, and then later we change this to maybe we accidentally wrote x times 1/2, so x divided by 2 instead of x to the 1/2 power. Since we wrote all of our documentation and our examples here, we'll be able to catch this error really easily, because we'll see, wait a minute, that one's a little more cryptic actually, but 2.5 squared, we expect 2.5, we got 3.125, and then we'll go back, take a closer look at our code, and we'll notice that, oh, this is only 1 star, this needs to be 2. There's the unfortunate case of the square root of 4 and 4 divided by 2 are both equal to 2. So for this example, if this were our only example, we actually wouldn't have caught this error. That's why it's really helpful to have multiple different examples. So change that back to the correct one. Run it again, and we see no output. Now we're going to do a brief overview of recursion. So this was one of the hardest concepts for me to understand when I was learning how to code. Hopefully it goes a little bit easier for you all. So we're going to go with factorials as a good example. That kind of fits the recursive model. A factorial is when you multiply a number by every number less than it, every integer. So like factorial of 5 would be 5 times 4 times 3 times 2 times 1. Yeah, all the way down to 1. So to write this in code, we're going to define a new function, call it factorial. We're going to take in x, which is an integer, and this will always return an integer because multiplication is a closed operation over the set of integers. Now we're going to generate our doc string. This is going to take the factorial of a number. X is number to take a factorial of, and it's going to return an integer, a factorial of x. No, these can seem really redundant for these simple examples, but when you start writing more complicated things, the parameters, the description, and the return value start to separate out a little bit more cleanly. Now, the examples. Let's say we'll start with our simple case. So the factorial of 1, that's just going to be 1 times 1, and that should be 1. Factorial of 1, we expect 1. Slightly more complicated case, factorial of 2. We're going to expect 2 times 1, so 2. And then something to show us that it's actually working, we'll take the factorial of, let's say, 4. And that should give us 4 times 3 times 2, which is 24. Now to actually write this, we're going to use a conditional, which we haven't covered yet, so it's okay if it doesn't make perfect sense. It's an if-else statement, so if condition is true, evaluate this block, else evaluate the other block. I think it'll become a bit more clear with an example. If it's not super obvious, don't worry, we're going to have a whole lecture on conditionals and control flows soon. So here we're going to say if x is equal to 1, then we're just going to return x. This is our base case. In recursive functions, it's functions that call themselves. You have a base case and then a recursive case. So the base case, to keep it from running for forever, is if x is equal to 1, just return x. Then else, we're going to return x times factorial of x minus 1. This is our recursive case. So in the case that we're calling factorial of 4. The first thing we have is we check if 4 is equal to 1, x is 4. It's not, so we're going to get to this else case. We're going to return 4 times factorial of 3. Is 3 equal to 1? Nope, so we're going to return 3 times factorial of 2, etc. And it builds on, so what this actually becomes is something like return 4 times 3 times 2 times 1, all the way down. And once you get to 1, then it's just return x. X is 1. So then this is going to evaluate to 24. And this is really just extra. So don't worry if it's not super clear. Now we're going to run this and see if it works with our test cases. And it looks like everything passed. A quick check to make sure it's actually running. You can just change this to something that should fail and then run it and make sure it fails. Yep, looks like it failed. So we know it's running, and that means that if it doesn't return any errors, it's running correctly. Just a quick overview of factorials. Awesome. Thank you all. I will see you in lecture or in lab on Wednesday.